Hello, my name is Mike Morris, and I am the owner and the founder of Spectracology. Well, I started in the industry, in a different industry, by making a product for the pet market, and particularly for measuring the pH of aquariums to protect the fish. And I did this when I was in grad school. My background is in oceanography. I was in the marine science department of University of South Florida. And had a growing family, and just living off a grad student's salary was not very good, so I decided to make a product I could sell. The Fish Doctor was the name of the company. It was also the product name, and I made these in a small shed in my backyard, and then we sold them through distributor into the pet industry, into pet shops. Well, I was still in grad school when I decided to leave and go to work for a NASA Technology Transfer Center. And my job there was to help inventors try to bring their products to market. So I learned a lot about that process. And I also was in charge of promoting a brand new program called the Small Business Innovation Research Grant Program. We ended up putting together a team, and we wrote a proposal to develop a pH sensor for the oceans. And that was part and parcel of the emerging idea of global warming and how the oceans might help solve that problem. So, surprise, we actually won the grant, and we got a phase one, which was 6 months, and a phase two, which is 2 years. When we got to phase two, we actually quit our jobs and went full-time work on that project. And the whole essence of the project was to take our Fish Doctor material, put it on the end of the optical fiber, and then we could deploy it in the oceans in a self-running, autonomous kind of instrument that could last for months and take pH readings up and down the water column. The problem was, once we had quit our jobs, is we discovered there was no such thing as a miniature spectrometer to put into the instrument. And in fact, we had actually had the instrument casing made, so we were stuck with the size we had. And so we had to go invent our own miniature spectrometer to make the project work. So at the end of the program, within a month, we are able to launch our very first product, and it was called the world's first miniature spectrometer. Well, one lesson we learned is that selling miniature fiber optic spectrometers was a lot different than selling big expensive spectrometers. Ours was 1,000 times smaller, 10 times less expensive. The only affordable way to do this was by phone. So we did all our sales and marketing by telephone. And then later, by the internet. The other thing we discovered is that there are thousands and thousands of people who wanted something like this. And we had no idea what they were trying to measure, or even what the industry was they were talking about often. And so we began to make extra things that could make the spectrometer work for that particular application. One of the very first examples was somebody called up and he wanted to measure how dark the characters were on printed checks, for the routing numbers. And they had to make a way to measure just the printed part, not the background. And so we came up with a fiber optic probe, had a bundle of fibers, and that was able to measure the reflection off that check. That reflection probe, now we have resold for many, many, many other applications. That same probe could measure the concentration of oxygenated hemoglobin in your tissue. It could measure the color off of printed materials for quality control. It could measure the chemical composition of solids. It could measure the reflection off of printed circuit boards. It was a very unique and very widespread use of that particular piece. And it really opened up our eyes to how widespread the applications can be. And so we shifted our focus from making a spectrophotometer system to making the tools that make spectrophotometer systems. And we did it in a modular way, so people could buy our parts and put together their own systems to do whatever their application was. As we did that, we invented 1.5 new products every week. And we also gained immense amount of application knowledge that we could cross-apply to different industries. So our primary goal was to provide the tools to the people who have the serious questions and serious investigations into what they need to know or what they need to monitor. Now we're understanding that the ecosystem is what keeps us alive and that we're all part of it. And so the scope of ecology is growing. And we had tools that could measure all kinds of things that are going on in ecosystems. So that was kind of the main idea behind forming Spectracology. If we focus on trying to make it easier for our customers to get their problem solved, we have to look at all aspects of that. And one of them is that you don't always know if a spectrometer is going to do the job for you. There's no way to know ahead of time until you actually try it. The other thing is not everybody has the budget to do it. And so we came up with the idea of rentals. And so we make rental systems. So what's the future hold for spectracology? Well, one of the things we discovered is that spectroscopy alone isn't always the best answer to all the problems that we want to solve. And since our real goal is to solve problems, we're expanding what we offer. And especially we're doing that through some strategic partnerships and from other relationships we have, but we're adding a whole line of hyperspectral imaging systems to our product line. We're offering handheld analytical systems like Raman spectroscopy to the product line, complete water analysis systems to the product line, and we're looking for other technologies that can broaden the horizon. One in particular, which is emerging, especially in ecology, is the use of genetic testing to understand the relationships amongst the different species and how that interacts.